All right, here we're going to take a look at page 2 of the applied statistics activity, and this is now we're looking at the standard deviation of the data, or how much spread of values do we have between the numbers. So here we have a little table that's going to help you build this out by hand. Here is x. X is going to be the number of data points. So here I'm going to put down each one of the data points that we had. So 3.8, I had two 3.9s, three 4.0s, three 4.1s, a 4.2, a 4.3, and a 4.4. Then I'm going to subtract, take x minus the mean. So in this scenario, my mean that I had, I'm going to put up above here, just that way as a reminder, we had 4.07. So from the front page, that was our mean. So we need that in order to make that happen. So what I'm going to do is on each one of these, I'm going to go ahead and I'm going to take that value, 3.8 minus 4.07, and that's going to give me a negative 0.27. Now what I'm going to do is I'm going to continue to follow this process. Then I'm just going to go ahead and I'm going to square it, because that's what the third column is it wants to take this answer, square it, and that's what I can go through and put. And I'm going to continue to work my way down until I have that there. Now 3.9, I have the same thing. Let me square this number. And same kind of scenario. So it's the exact same process as we go down through each row of the table. Let me get this down. Then, once I have the table all filled out, I'm going to add up all these numbers that are in this third column. So I'm able to go through and just start adding them up. Okay, I'm going to get a sum of 0.3268. And what I'm going to use that for is that my standard deviation, so there's my little symbol for standard deviation, which is sigma, is equal to taking the square root of the sum of x minus the mean squared divided by the number of data points that I have. So I'm going to go ahead and plug this in. Square root of 0.3268 divided by, there's 12 data points, and I can go ahead and solve for my standard deviation. So I'm going to go ahead and take the second square root, 0.3268, divided by 12, and here I get a standard deviation of 0.16, and usually they want us to go through and again go out to about 1 decimal place. past the original data set. So this right here, I'm actually going to go ahead and say, well, that's actually 0.17 for my data set. Because if you remember, the original data points only have one decimal place. This one has two. So this is going to be the way we want to express our final answer. The last portion is going to have us creating a histogram. So the histogram setup here is going to allow us to go through and set up our particular data points. So I'm going to go ahead and put a little dot right about there. And then what I'm going to do, I'm going to draw a little axis, vertical axis here, and an axis going out this way. So what we're going to end up doing is down here along the x-axis, I'm going to put, covering two boxes here, I'm going to put a data point. And I'm going to continue to go down until I have all the data points being represented. And then here would be 0. I'm going to go up, I'm going to skip 2 lines, just so that way it goes through. I'm only going to go up to 4. So what we're going to put in here is that 3.8. How many of these did we have show up? Well, we only had to go up to 1. So I'm going to go ahead and I'm going to kind of fill that in a little bit. 3.9, we went up to 2. So again, I'm able to kind of see how many did I have. 4.0 went up to 3. Same thing on 4.1. 4.2 only had 1. I can go ahead and put in my bars here. And the same thing with 4.3, 4.4. So, and usually I like to shade in or kind of fill in these bars a little bit. So that way it's really easy to see where they're kind of hitting at on our chart. So we're just representing the data with a graph. And so what we might want to put over here is, this is the frequency, and this one here we'll record as being the depth in centimeters. And that's going to show us our histogram. Now the question is what class interval would be appropriate for numbers to be reported as 4.1 centimeters? So as you go through and you start to look at it, it's like, okay, well, if we want to round, if we wanted to express a number to be 4.1 centimeters, this would be the lowest number because the 5 would round up the 0 to a 1. So I can say, okay, it's got to be greater than or equal to that. X is somewhere in there. And it's got to be, less than or equal to 4.14. Or you could also express it also as like this, 4.05. Got to be less than 4.15. So, because as soon as you get to 5, that I have to round up to 4.2. So either way, a lot of those ranges, either one of those ranges would work for this. And as you're taking a look at conclusion question number 1, just to give you a little hint, which step of the design process, think about your evaluation. Are you evaluating, is your connector part really going through and meeting the criteria that it needs to of the design? So think about some of those steps of the design process. Where would that best be useful?